The other one is utilizing satellite images and in-field images to better understand what are the current practices uh, in the ground. So in terms of tillage, so we are pairing up in-field images with satellite images to prescribe to make an inventory of what is the current state and what are the current practices for tillage in the soil, so that we can have a what is the current state, so that we can plan ahead on how do we incentivize potential cover crop
Okay.
no-till usage, and so forth.
Welcome to the Crop Science Podcast Show, brought to you by Wise Genetics. I am Brian Arnell, and I'm coming to you from the campus of Oklahoma State University. Today we have on with us Dr. Daniela Jones, Assistant Professor in the Biological and Agriculture Engineering Department at North Carolina State University. Dr. Jones holds a joint faculty appointment with Idaho National Laboratory. At NC State, Dr. Jones is also the Data Science Academy Director of Agricultural Analytics, Director of Agriculture Data Science Certificate, Office of Research and Innovation Faculty Fellow, Graduate Faculty of Operations Research Program, and Faculty Fellow of the Center of Geospatial Analytics. Nanny, that is a lot. That list is significantly long. So thank you for taking the time out of your day to join us.
Thank you for having me.
So, Dr. Jones, tell us a little bit about your progression to end up at NC State. Why did you end up in this agriculture analytics sector?
So my background is industrial engineering, and so I wanted to be an engineer for my whole life. And then data was a big portion of it. I just happened to be an undergraduate researcher at some point, where a professor pulled me aside and asked, "Do you want to do undergraduate research on health or on sustainability with using, agricultural products for biofuels and bioenergy, and combating per se this changing climate?" So I chose the latter, and then after that, that's where my career in this biofuels and data analytics work and agricultural products started. Through my path, I've been able to work with Idaho National Lab, Oak Ridge National Lab as well, and then I ended up at North Carolina State University because I moved because of family, but also I was lucky that NC State has a great program in engineering, and as the data boom was happening in the world of agriculture, and how we could I ended up in here, and I'm happy that it all worked out how it did.
So, where are you from originally? I have to ask.
I'm originally from Peru, then masters in and bachelor's in Mississippi State, Texas A&M, and now Duke, and then North Carolina State University.
Awesome. I always love the lineage of education, right? It always knowing where somebody comes from, the schools, and even the major professors they work with. It kind of gives you an insight sometimes about their approach and some of the take on things. So, tell us a little bit about what are the current projects in your lab right now? What are you guys doing?
Yes, we have three start projects at various different scales. For example, my biofuel work is in conjunction with Idaho and Oak Ridge National Lab. We're trying to figure out how do we create this bioeconomy nationwide. Do we have enough resources to be able to make it competitive when compared to the petroleum industry? How do we move this forward? How do we talk with growers to be able to actually purchase their residues, if it's corn, or work with them to figure out how do we help them implement intermediate crops in the winter months for so that it doesn't affect their conventional crops. And that one is, we use operations research for figuring out the supply chain of biomass for biofuels. That is one of my key projects. I have three. The other one is utilizing satellite images and in-field images to better understand what are the current practices uh, in the ground. So in terms of tillage, so we are pairing up in-field images with satellite images to prescribe to make an inventory of what is the current state and what are the current practices for tillage in the soil, so that we can have a what is the current state, so that we can plan ahead on how do we incentivize potential cover crop usage,
Okay.
no-till usage, and so forth. And the last one is more of a local scale. Here in North Carolina, we are the the biggest producers of sweet potato in the whole
Hmm.
nation, and sweet potato is hand harvested, and we all go to the grocery store and look at this different sweet potatoes, and we all participate as judges of this beauty pageant while at the produce, and we always pick the best one that appeals to our eyes, but really that's not what happens at the field. There's different forms and sizes and shapes, but the farmers are continuously working towards trying to get the most symmetrical potato. So we're using machine learning to understand what are the factors that are affecting these different shapes and sizes. How do we store the images that are taken at the packing line, and um, how do we pair up those images with provenance and what happened at the field and so forth, so that is another data analytics project that I'm in.
That's fascinating. Okay, so I got to get my bearings around me because you've described a very diverse portfolio of research, and so it's really fun. So I want to go back. We'll start at number one with the biofuels.
Uh,
Can you describe what you mean by operational research? Because I believe you use the term operational research. Can you give a little teardown of what that means?
Absolutely. Operations research is a concentration in an industrial engineering. Some will differ with me saying that. But what we do is optimization. So mathematical models where you have this objective, maximize the amount of production that you get, or minimize cost so that you can get a particular demand. So we're trying to see where would you locate this biomass, biorefineries, where would you get this biomass from, so that it is economical, so that it makes sense. We all know that usually corn stover would be, or it would be collected today in bales, and bales are bulky, bales are not dense, and in the end of the day, we want to get energy out of that. So we have to figure out strategies to perhaps densify it into a pellet format. But
Hmm.
where in space do we uh, create this facility, because the longer you ship a bale, the more expensive it becomes. But once you densify it, then you can ship it at a lower rate and so forth. So those are the questions that we're trying to ask.
So if we look at that, if we look at the I guess the improving the integration of biofuels in the system, is there a problem or a pinch point that has been identified that may have surprised you? Something you didn't expect to see when you started this research, as far as I didn't see that as being a problem, but all of a sudden it's a pinch point?
Yes, for the longest time, in from what I've seen, others will differ. Um, we have been trying to create this bioeconomy, assuming that the farmers will accept the price for their residue, and without potentially understanding how a field works, how if you collect that crop residue, it has an impact on your soil. It has an impact on the yield for the next year. So more and more, the Department of Energy now, I'm a lot more excited, or this has happened more recently. The Department of Energy now is also working with USDA to try
Hmm.
to integrate this research topics, and um, uh, including in our analysis not only the cost but also the material quality and how it impacts the grower, in looping them into the decision making.
Yeah, so it's always been interesting looking at this, especially the corn stover and some of this biofuels for the or the biomass for biofuel. As a soil scientist, that's the last thing I want to do is remove that stover. So for me in the current time, as we see such a drive for soil health and regenerative management practices, the use of corn stover for biofuels is an antagonist to uh, soil organic matter, soil nutrient cycling, and biological activity. And so that in itself is a little bit of a challenge that I think that even the government has two opposing views of. If you look at maybe the USDA versus the DOE.
Mm-hmm. Yeah, absolutely agree. Yes.
So I guess we'll move. Is there anything else within this biofuels work that you're doing that is exciting you or it's surprising you? Just anything along those lines that I'm missing?
I think it has highlighted the absolute need of interdisciplinary research.
Mm-hmm.
We didn't include a soil scientist, or we would not get this pushback towards soil health. Um, as minimum as a recent story, we were, people at in the energy industry talking about uh, harvesting winter crops, oil in particular, and calling them cover crops. But a soil scientist will tell us you cannot call it a cover crop if you are harvesting. So
Mm-hmm.
the minimum, the details, the for us to be able to tackle these grand challenges, we're going to have to understand that we need to bring everyone at the table, everyone with its different backgrounds, so that we can actually find solutions and include every stakeholder throughout the supply chain.
Well, I think it's absolutely fascinating the just the timing of our podcast right now of this interview with you, because I just recently was reached out by somebody looking at using semi-arid grazing and grasslands for carbon storage as a carbon sink, where they're going to harvest the grass and the biomass from these semi-arid regions and store them as a carbon sink. And they want to know a soil scientist's opinion and an agronomist's opinion. And I'm going to say that probably has limitations, especially in a semi-arid environment. That the Great Plains would be our Western Great Plains from the Western North Dakota, Saskatchewan, all the way down to Texas. Removing our biomass isn't always the best idea when we only get 15 inches of rainfall. So that's absolutely fascinating, and the integration of multiple disciplines has been extremely important in my entire career. My background is working with agronomists and engineers, both electrical and mechanical, and seeing the interaction of soil scientists, water scientists, mechanical and electrical engineers, and the different questions each ask. Every one of the disciplines comes in with a different base question, and that in itself has so much value.
I absolutely agree. I absolutely agree. And I try, we're both faculty members and we both have students that we're working with. I tried to bring that diverse background into my lab as well. We have
Mhm.
an agronomist. I have an operations research student. And a mathematician and electrical and computer engineering background, and try to bring that diversity to this problem solving.
So now moving on to your second project, Dr. Jones, and I got a couple questions on it. It's intriguing.
Mhm.
So my first question is more a 100,000 foot level question. Who are who is interested in this data that you're wanting to collect on tillage? Is it a governmental? Is it a commodity? Is it local? Who wants to know this information that you're collecting about the tillage situations of fields?
As researchers, as academia, we're working towards the better of the society, the community as a whole.
Hmm.
In my opinion, in the federal perspective, they get to better understand what is the land use right now, or practices, and how do we make policies to incentivize towards a common goal for a grower, for a farmer. Potentially, the they get to better utilize data driven platforms to make those decisions. If I am a grower that handles multiple different
Hmm.
fields across a broad area, if I can utilize satellite images to better understand my soil rather than having to physically go there,
Hmm.
I'm hoping that that is also supporting, that decision making, getting that understanding of what's happening in your soul. How did it impact what I did last year or what I did this year? How it's going to impact in the future, and how can I utilize my actions to get an incentive, perhaps, to understand how to better um, improve the health of my soul and so forth. So it serves both stakeholders, in my opinion.
So, my next question along the lines of this project is you mentioned satellite, which is an easy thing to comprehend. When it comes to your second project, you mentioned satellite imagery, which is an easy thing to comprehend. What do you mean in terms of in-field imagery? What is the source of this data coming in?
For us to utilize machine learning, um, we have to have a ground truth data set,
Hmm.
labeled data set. So if we know is in this field they have done 20% tillage, or a range of tillage, then we can tell our models, this particular field has 20% tillage. If we go back to the pixel that represents, or the group of pixels that represents that field, this is what it looks like for the satellite image. Then we start creating our data set that is labeled as whether what percent of tillage, and then we can broadcast or extrapolate from that information with machine learning to better understand a broader area.
I've got like two questions. This is wonderful. I love this. So, my first question is, who do you have collecting this data? Are you sending out an undergrad or a grad, or are you using the producers and the farmers and ranchers to do the data collection, or a combination?
So this particular research is in combination with researchers at USDA and USGS. Um, they have been collecting this data for years now. I believe we have 7 years in the data processing. So it is the people that have been collected and are researchers from USDA in partnership with the farmers, the growers in there.
And so, and I'll go back. My other comment or point was, I'm glad that you said ground truthing, because as I meet new scientists, so I'm as an agronomist soil scientist, the ground and being on site has a lot of value and importance. And I tried in my class of precision ag, especially those that are very model based and data driven, the importance of, especially with new data, the need for validation, or as you air quoted, ground truthing, because that's a kind of a weird term that I get in trouble for because I use it often. But even with our satellite imagery right now, I've been involved in using active sensors for prediction of biomass and nitrogen for 20 years. I can't use any passive imagery utilizing those old models without some ground truth and correction because of the inaccuracies of a passive sensor being from satellite, plane, or drone in relationship to the traditional active light, which is a higher repeatable value from those old sensors in the 90s and 2000s, where a lot of that early work was done. So I love to hear the acknowledgement sometimes, I guess, on my side, that there's still a need for that validation point, because some academics almost forget that they have so much faith in the data, so much faith in the stuff, that we can go forward and in private and public sectors. I've heard of many failures because of the assumptions made without validation.
Right, right.
So moving on, I think we got a perfect amount of time to wrap up. Probably what I think is one of the most unique projects I've been presented with as a host on this, figuring out the shape of sweet potatoes. That's just because in my mind there's so much going on. You have shape recognition, you have marketability, what's the desire, so you have the consumer side, you have the machine side, the figuring out the shape and that, and then leading back to the soils and agronomy and environment, which led to the shape that led to the marketability. So please, Danny, spend a little bit of time and dive a little bit more into this project.
Yeah, I agree. I think this is the most exciting project to talk about always. Yeah, we are working. We're lucky that we have been able to develop data use agreements with actual packers that handle multiple different fields, and that in itself, it's a big undertaking. Trying to better understand, have regular meetings with them, where we want to make sure also to be conscious of their time, so that so throughout the meetings, for example, these are monthly meetings. We are making sure that we understand their process. We're not trying to impose a new way of doing things, and doing research to the best of our ability where it doesn't interfere with their current workflow, because at the end of the day, this is an industry. So through the process, we have been able to understand how they're packing, how, for example, right now, when a bin of sweet potatoes comes in, the main classifier for that, the grade of those sweet potato is one. It's either a US grade number one, or a all mainly petites, or so forth. But computer vision can help us create an actual distribution of how many of this category, how many of that category. Because if it's too big, it can go to, for example, the baby food creation, or frozen food, or animal food. If it's too small, then it goes to a particular price on the produce section. If it's in the middle, then there's your higher profit. So we get to understand the variability of how they do business, and how they fulfill orders. How sometimes even they every single one of their customers has a different metric for what they want, and it's not, in shape and size. It involves weight, it involves length, it involves the width as well, and the symmetry. So it is a lot of a great work that it wouldn't have been able to be realized without interdisciplinary research. We work with soil scientists, we work with electrical and computer engineers, agronomists, and so forth. That together we're trying to arrive at a conclusion. And again, it's a big part of that project, of the success of that project, is having the stakeholder in mind, the person that is actually going to use that technology, and having them in the process of creating this technology.
So where in the supply chain do you see this fitting? Is this on farm or is this downstream?
All the way from farm, at harvest mainly, and then all the way to it goes to the storage, and then a packing line, and fulfilling the order.
Okay. That's fascinating. So, how do you, as a lead scientist, how do you get your students involved with this research? How do you work around? Because you've already mentioned that while you're very much into interdisciplinary work, you want interdisciplinary team. So, how do you work around that and get them all involved?
So each, with when training, as you know, PhD students or master's students, they have to have their independent project. So I make sure that they know which one is their project, and it for a student, it takes a while to understand that that is their project. It takes a while to take that, mm, as a lead of the project. So they are very, as I mentioned, they're very distinct projects that I'm working with. I make sure that they know what is their main task. But as each one is going through their training, they will see that they all go through the similar challenges. The person that is the biggest modeler perhaps can help the others better understand how do you divide your data, so that you can have a holdout and a validation and so forth, for machine learning. The other one can better, the agronomies can better help the other ones understand how what are the interactions between carbon and nitrogen within the soil and how it goes to the plant and so forth. So to the best of my ability, I do try for them to talk about the research among themselves, and but also know that they have their own independent project that they're leading, and empower them with the fact that that is their project in the end.
It's time for our famous three.
Wisenetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
Dr. Jones, I love the excitement you bring, so I'm going to wrap up with one last question. What is the most rewarding moment in your career so far?
Graduating my first PhD student. I think that's what it was. And I may or may not have cried while
Completely understand. I am the same. The students are my most prized outputs and most prized everything is that just love seeing them go out and work. And I've been blessed to have quite a few now run through my program. Well, as we wrap up, we're hitting the end of time, so we're going to hit our 3 follow-up questions I always ask. So, Dr. Jones, where do you go when you have such a diverse portfolio of research? Where do you go when you have questions about sweet potatoes or about biofuels?
People. My best resource is my colleagues, my students, and the industry partners that I have been privileged to be able to work with.
Holly, and I can't imagine you have much of this, but what do you like to do in your free time?
Take care of my 3 kids.
You have no free time, so yes, okay. How old are your kids?
5, 2, and 6 months.
Oh my, you've got your hands full. So awesome. Danielle, where do people go to find more about your work and the work that your lab's putting out?
I have a lab website, drdanijones.com.
Fantastic. Well, folks, that wraps up another episode of the Crop Science Podcast Show presented by Wisenetics. Thank you for joining us today with our guest, Dr. Daniela Jones, Assistant Professor in the Biological and Agriculture Engineering Department at North Carolina State University. If you enjoyed this podcast, hit that subscribe channel so that you get a notification every time a new one's released. Also, share this video with your friends, colleagues, and peers, somebody you think might find interest in either biofuels or sweet potatoes, or anything in between. Of course, leave us a comment if you have any questions or suggestions for a new guest. Thanks so much for joining us today. This has been an absolute pleasure.